Good afternoon and welcome to this webinar. So the unconventional gas exploration and new technologies developed for ConocoPhillips. So in this webinar we are talking about some new aspects of the unconventional gas exploration and new technologies developed for ConocoPhillips. So in this moment you have principal 6 topics: why explore unconventional resource and conventional gas, what is the unconventional gas resource, price and revenue, what kind of technologies can support the unconventional gas exploration, and in this occasion we are pleased to present also the new technologies developing for ConocoPhillips, the quantum gravitors. The quantum graviter, join multiple drilling wells, and so another technology is to join multiple drilling wells, small diameters, with a single storage system, support the local economy with and show you some projects that are involved with ConocoPhillips. So the first topic is why explore the unconventional gas. What does it mean? So typical unconventional gas is shale gas, natural gas trapped with low permeability shale formation, often requires hydraulic fracture to release the gas. First type is in the shale gas. We can have also cold bed methane. The methane absorbed in coal seams, released by pumping out formation water to reduce pressure. And you have the tight gas, natural gas held in low permeability sandstone or carbonate reservoir. And finally we have the first type is the gas hydrate. Ice leak structure found in deep sea sediment and permafrost that trap methane molecules. Which are the key characteristic and distinction of this type of resource. Generally, we need special techniques for extraction. These resources require specialized methods such as horizontal drilling, hydraulic fracture, and or CBM or dewatering. So the geological structure that contains these types of unconventional gas, they are not trapped easily and inaccessible or with standard porous rock, but we are dispersed over large and continuous area. So we have some trouble, we have some challenges in exploration, but also in develop this type of fields, and we support ConocoPhillips in this part. We are proud to support ConocoPhillips in this part with some new technologies for captures. And risk and challenge: the extraction involves high financial cost and technical risk compared to conventional methods. The environmental impact: life cycle emission for conventional gas. We also make attention to environment impact. The life cycle emission for conventional gas can range from 6 low to 40% higher than conventional natural gas. So this is the map, the latest map of global unconventional gas phenomena recovered in the last 10 years. We have an important presence of ConocoPhillips, for example, in North America, Alaska, Canada, and like this, but we have also other possibility to develop other potential unconventional gas resource, for example, in Australia, South Africa, we have in China, in shale, we have shale gas and tight oil, and in particular, for example, Alaska and Canada, we are rich on shale gas and tight oil. Also, United States in shale gas and tight oil. In Europe, we have the presence presence of shale gas, for example, in Poland, and other places like Qatar or Mozambique, and especially with the shale gas. And we have also the South Africa, and like this. This is a recent map of ConocoPhillips are present today, for example, in North America, South Africa, and Australia. Topics: what is the unconventional gas resource? So the second topic is what is the unconventional gas resource? Typical source rocks for unconventional gas are organic, rich, fine-grained sediment rock, most notably shale and coal seams. For coal seams gas, we can distinguish coal seam gas and methane. We can have different type and gradation of gas with butane, ethane, and other else. The other significant with the less common source include tight sandstone. Generally, we are trapped in the tight sandstone in siltstone and carbonate that act as both the source and the reservoir, are both source and reservoir. This is a characteristic of unconventional gas that will be contained in sandstone and carbonate. Unconventional gas type and their rocks. We have shale gas, organic rich shale. The shale itself, source rocked, generally for shale gas, the source rock is in an organic shale, and the storage was made the shale itself. For coal bed methane, it's the cool seams, and the tight gas is underlying or nearly in the shale, and the storage generally was made in low permeability sandstone or carbonate. For biogenic gas, we are referred to Cenozoic rock or shallow organic sediment near source uncompacted sands and silt. What is the unconventional? So when we are talking about, for example, of coal seams, the source and the host for coal-bedded methane, or also called CBM, the methane is generated during the qualification process. Is the process that bring in carboniferous rock, where plant matter is transformed into coal. It generates both coal and methane under the heat and pressure. So we can do this, for example, and also in some context of metamorphic generation. The tight carbonates, some unconventional gases sourced from and trapped with low permeability limestone or merely limestone. These often contain the types 2 and 3 of kerogens. And for organic shales, we are much more different case. They must contain sufficient organic materials, typical with TCO measured than 1, 2 or 3%, and they have reached thermal maturity to generate gas. Typical source rock for unconventional gas are organic rich, fine-grained sediment rocks, and we have the most notably shale for shale gas and coal seams for this type of coal seams gas of methane. Other significant and less common sources include tight sandstone, siltstone, and carbonate, and that the fact is that both can be source and reservoir. Which are the key geological characteristics for kerogen types? Source rock contains generally type free of kerogen. Terrestrial plants was made by terrestrial plants. It derives from decomposition of terrestrial plants, are typically gas prone, while type 2 are from marine generation, can produce both oil and gas depending on maturity. The thermal maturity for thermogenic and conventional gas source rocks must be reached than gas window. So actually in the world and for by ConocoPhillips, the total exploration programs is estimated for the 2027 and 2028 in an investment of around for $45 million. The typical covers clear the pre-screening survey, geophysical survey, seismic data map and formation, and after we have the appraisal with the exploration and wildcat, initial vertical wells to core and log the rocks, the appraisal with the pilot wells. So this is an estimation for the next 2 years. What is the unconventional gas resource? Typical source rock. We have just seen this. Okay, finally we can have other significant and less data. A measure comparison, for example, with the exploration well, the cost, the typical range of cost. It can be much changed by the regional geology and the complexity of projects. We see the typical case that we are working with ConocoPhillips in the case of Alaska. This is one of the major ConocoPhillips investment. This is the contour bed situation with shale oil, recovered this, and shale gas. We have a new adaptive exploration technique for unconventional gas resource. The resolution typically, we are developing this in branch with ConocoPhillips, we are developing this. The new advanced technique for unconventional gas resource, typically we have a vertical resolution of 2.5 millimeters. The circumference coverage is about from 18 to 19% of borehole well. The pad sensor, we are using this pad sensor, and these tools produce a spherical electrical image along the borehole well, similar to an unwrapped photograph. What we are trying to detect with this new kind of technology, we are trying to detect open fracture, and so it's much more to estimate the conductivity along, for example, wells, the conductivity inside, and the gas migration. We have also the feature calcite field fracture, the resistivity sinusoid. We are also mapping the lamination when we are when we are working, for example, in tight gas and sandstone and or in turbidity sequence. The fault, the disrupted band in the structure control, the breakout energy dark zone. New advanced exploration techniques applies, for example, also in horizontal shale gas well. In horizontal wells, electrical image help to establish and study the land zone optimization, find the brittle layers suitability for hydraulic fracture. The fracture orientation is much more important to determine to understand and determine the maximum horizontal stress, the natural fracture set, the optimized horizontal well azimuth, and the storage spacing. So we have different local types gamma ray. We are making a comparison of techniques that today are used and new techniques that we are improved for ConocoPhillips. The gamma ray is a resolution between 13 to 60 centimeters, so the density is around from 20 to 30 centimeters. Sonic logs have a general resolution of 30 centimeters. Today, with new scanning electrical image, we are improving a resolution of 2 or 5 millimeters. This is an example of applying new scan electrical image. Example of overall electrical new scanning electrical image. We are recovering of type. We are mapping of type of fracture, and we are classifying the type of fracture, the fracture that was still open, the fracture that was filled out, for example, or filled by calcite, and we have different resistivity. Is much more important because, for example, if you have this type of fracture refilled by calcite, you can easily frac this with different type of techniques. It's much more important to study this, to have a planning, for example, of frac technique that we can use. We have laminated bending or breakout borehole stress. So this is a plot also of gamma ray RP value, and like this. ConocoPhillips Unconventional Gas moves also to gas, to Australia gas project exploration. So this is the case of Ottaway Basin. In the Ottaway Basin we have exploration wells 1, 2, and the gas processing plants that we are planning to build. And we have fields and discovered gas. We have discovered in this case 2 fields: the gas condensate, a field with gas condensate, we field with gas cold bed. Plus we have other active license. ConocoPhillips Unconventional Gas has a great presence also in South Africa. The Whittle Formation that is show you in this photo. The Whittle Formation is characterized, for example, by high total organic carbon content up. In this case, the TOC is measured than 14%. High thermal maturity. We have a thermal maturity. We have a raw estimation of 1 or 4%. We have a very typical of this formation. We have a high content of quartz. Quartz is around 50% average with carbonate-rich intervals and sufficient thickness for commercial development of 50 meters average. The actually legal concession and legacy exploration data demonstrates that is a regional continuous over some this structure, this very particular structure that I can see you in this cross section is extended for over 2,000 kilometers and buried to depth up of 4 kilometers in depth in the extreme south of the basin. So this is in the extreme south of the basin. So the ConocoPhillips Unconventional Gas in South Africa, we have shale, we have a great evidence by this data. We have great evidence of shale gas. Shale gas in first well exploration appraisal. This is the data from first well appraisal. We have the sample rock, the Tyberg, we have the Collingham and the Whittle. So the depth is around, you can see the value of TOC, TRC really increase in white till formation. White till formation is the carbonate, is the formation that I described you in the present in the past with the TRC up around 40%, around measured than 5%. So the wet till formation is recovered, started from 420 20 meters. So it's not an optimal depth. We have find the optimum location for shale gas exploration in this area that is called Kuru shale gas area in the Falcon. ConocoPhillips Unconventional Gas in South Africa. Shale gas evidence in first exploration well. We have the evidence in the shale gas in the first exploration well, but is a complex mix in this case, but because we have the real surprise that is not only called unconventional gas, shale gas, but as you can see we have also a good index in the deepest part of wet till formation. We have a good index of hydrogen, so it's really surprised by the exploration geology that recovery and a high index of hydrogen nitrogen part. We have some trouble. It's clear because this hydrogen is linked to the presence of pyrolytic mineral. So we have an explosion situation, and so we are proved to, in this case, we are really proved to apply the new technology developed for Schlumberger that is called electrofracking. The electrofracking is for the first one applied in this case for microfracture control, and permitted with a very successful application for the extraction both of shale gas and hydrogen. And we have also the recovery of a great percentage of hydrogen. So the first well appraised have a successful recovery of both of gas and hydrogen applying the Schlumberger electrofracking. So in the presence of ConocoPhillips in South Africa is starting from around 20 years ago, and are developing complex. And today we are developing, as we just show you, a complex, and we are developing a complex and integrated project for unconventional gas, but we have also the surprise of hydrogen. And unconventional gas and hydrogen, probably we have a request also for CO2 reinjection, and we want to improve also geothermal for local and circular economy, developing local growth, future expansion. So the portfolio is really in growth. They are creating value for, in this case, we are creating value in an ethical way, triggering the circular economy process from shale gas to hydrogen and geothermal energy. And we have created a plant laboratory in this case. So ConocoPhillips is still moving also to bioenergy production with other partners. Is a major partner also of APL Energy in Australia. We have a portfolio for bioenergy, but we want to, in this case, use this webinar also to present the latest technology that we are developing for ConocoPhillips, that is called the quantum gravitors. So today the advanced seismic method acquisition integrated with mapping, for example, aerial and marine geophysical acquisition, some is not successfully all time for the very high thin resolution of identifying the shale gas repository. So this way, from this necessity, ConocoPhillips committed us to develop a new way, a new technology of expression that is called quantum gravitors. What we are doing with these new tools, we have a high resolution 3D seismic mandatory, dense resistivity and source spacing with azimuth and full azimuth phase acquisition, and quantum graviter on board of AUV survey. The new technologies of quantum graviter on board of AUV survey permitted this incredible target. We have a target size of 10 meters in vertical at depth of 2 kilometers and marginally detected, target size of 50 meters in vertical when we have easy detection, and when you go out of 4 kilometers you have this target size, strongly detected. So the new technologies is represented for the quantum gravitors can be mounted also on drone or small copter, and depth image below surface we have an anomalous target at, for example, of 2 kilometers is just tested in the wet hill formation. So the quantum gravity data sensor with the ultra sensor and seismic image. We integrated the quantum graviter data, the gravimetric data with high GPR data and high resolution seismic image. To have what we can produce a gravity anomaly map density construct with the resolution of 10 meters in vertical that can be easily detected of change in thin layers, thin geological layers, seismic image of structure and structural mapping. Finally, we can produce an integrated 3D model of gas and hydrogen reservoir. That is the case which have surprising wet hill formation, and from what we are really apprised from the South Africa developing this new era of energy. The fly survey altitude is very low, between 10 to 50 meters elevation, with the line spacing of 10 to 12 meters line spacing. We have some partnership with technologies university for develop this, it's clear. Research of V and quantum graviter is still proceeding. What is quantum graviter? Quantum graviter measures the gravity by tracking the phase difference between two matters waves path of laser cool atom in a free fall. So atom that fall, generally all atom that can be fall by the center, and we have a different construct between the atom that is made the rocks and the gas. So quantum graviter incredibly relieves this difference. Why we use quantum? We use wave quantum because we can use this in all of weather condition in extremely efficient, and can detect in change in G, in gravimetric acceleration in a sensitive 10 elevator 9. Essentially, quantum gravity is an atom interferometer. So vacuum chamber with atom source, laser and cooling, will hit cold atoms that generally we have a sensibility to the temperature because the gas we are generally too cold instead of the rocks, and the source laser pulse redirected the path. We have a beam rebicamery, and the third pulse rebicamery the path, and we have this law, the different in phase measured. We have interference. The points that are not aligned with generally is represented the trapped gas, the bubble of a gas. Field using gravity survey, it's clear that we are using this, for example, for mining mineral, but also for water exploration. Quantum gravity measure gravity using cold atom interferometry rather than classical spring-based of strap-down system. Instead of mechanical mass like classical gravimeters, you don't have in this case you don't have a mechanical mass that make the interferences. So all is made by the interferogram of the response of atoms, and it uses atoms behaving as waves. Atoms like rubidium or calcium are cooled using laser to near the absolute zero temperature. We measure the thin change in gravity by tracking the free fall of ultra-cold atoms using quantum mechanics. The principle is simple. Gravity is measured from the acceleration of atom in a free fall or in a free movement, where the change of velocity is change the velocity of atoms. Change of velocity in this case is change velocity of atoms. So it's clear that the gas that was micro-trapped in the rocks have a clear response, have a clear acceleration, a measured acceleration than the atom of the rocks. So you can easily find it all of micro cavity with gas. Inside the quantum graviter is a very complex structure and a fascinating structure. So quantum graviter measures gravity using cold atom interferometer rather than classical spring-based or strap-down system. Instead of mechanical mass like classical gravimeters, we use the atom like rubidium and Celsius to calibrate of this. This is a clear laboratory testing sequences, atom interferometer, the heat of the gravimeter. The device used in March-December of last year. Last pulse split, we have the detection in the 4 point we are out to measure the gravity using the gravimeter, this coefficient with kappa and g, and time, that is the time that detected by the table of acceleration. Finally, you have detection of turning atoms back into light. When the atom was accelerated, we have a response in light. So after falling, the atoms are illuminated with another laser. Atom emitted fluorescence light, and a detector measures the interference of pattern, the interference of fluorescence. So the position of the fingers gives the phase, and in the sixth phase, shift to gravity. Quantum gravity is really a function for these topics. What the quantum gravity actual measure? What is able to measure quantum gravity? It is measure difference in gravity over a gas reservoir or over a void or pocket, for example, wiki gravity. We measure the change in gravity reveals the mass of underground structure, the density change, gas or minerals or cavities, and what is the sensitive of quantum gravimeters. Ultra cold atoms, extremely stable also for wave naturally preserved. We can detect 10 meters anomalies. We can detect in anomalies with a range of 10 meters at depth of 2 kilometers. Gravity change has really small and density variation of 1 kilogram by 1 meters cube. So 1 kilos for 1 meter cubes. If you consider that the rocks can contain gas, can have a weight, a volume of weight of 0.998, and rock that not contain a gas but is a crystalline structure have a weight of volume around 1.8 kilos by meters cube, you can easily make a distinction by these two targets. Summary: cool atoms too near to absolute zero, put them in a free fall inside a vacuum and measure the thin phase shift caused by the gravity and convert it in shift phase. How is made the internal part? We have a motion acceleration effects. It's clear we need to adapt this system for any of V to fit the acceleration, the tilt, the runs, and the wind. And we need also a IMU platform with GPS correction. So the practical constraints, we need to apply a constant velocity fly and non-aggressive maneuvers. We also need attention to temperature stability. Laser and optical spark are really sensitive to change of temperature. The drift effects phase were measured and need to correct. We need a thermal a sensor for a thermal control of 0.1 Celsius degree, insulated sensor housing, and we have vacuum integrated, sensitive to pressure leaks and mechanical shocks. We can combine also quantum gravimeters with an hybrid approach with the seismic approach. Quantum AUV gravimetry detects density anomalies, AUV or small airborne seismic, resolve structure details and vertical layering. Integration: we produce high resolution 3D model of gas and hydrogen. In this case, the quantum gravimeter survey flies grids over target an area of an altitude between 10 to 50 meters. The data processing: we are filtering the AUV vibration and noise integrity, invert gravity data to subsurface dense constants, combined with existing seismic or AUV seismic data. So the target identification, the detect anomalies from with a range of or scale between 10 meters to 200 meters, map precise depth and vertical extent. New technologies: quantum gravimeter dimension and weight, which is effectively the dimension of quantum gravimeters. We are collaborate with University of some university, also local university, and we are resides. So the ideal configuration of quantum gravimeter, we have a weight of 25 kilos. Stabilization system is around a weight of 10 kilos. We have a total payload of 14 kilos. 14 kilos today with actual technologies of drone or AUV is a very transportable on small copter or like this. Key insight for project: 4-year goal, 10 meters anomalies at 2 meters depth. Today this is the standard. Relieve 10 meters anomalies of density constant at 2 kilometers depth. You must use quantum gravimeter, you must stay below with the payload on AUV of 14 kilos payload, and you must ensure that you have a totally extreme stabilization of fly survey. The advanced prototype, best current developed, You have a sensor read of vacuum and optics, laser module and electronics, and we have a totally integrated, we want to reduce of around 10 kilos the weight. So it's clear that in this case, make an analysis of dimension, weight, category, current, how V is capable to transport quantum gravity. We have a feasibility today, just a feasibility for the existing model. The optimized design that we are working on, we advanced prototype, and the emerging tech with the future miniaturized with this dimension, 20, 30 centimeters. We are mounted to all operation battery with this characteristic from 14-16 amperes. Flight time is around 20 to 13 meters. Hybrid configuration with full engine and generator with the 5 or 18 kilovolt continuous flight time from 1 or 3 hours. This is the advanced model. What we have on board, we have RT Kappa GPS technology, ENS fusion, terrain following radar or LIDAR, autonomous fly capability, precision waypoint spacing, 10 to 12 meters, and we have a payload, 14 quantum gravitational system, and we have servo capability that, as just say, mission requirements. In your case, payload is actually a maximum of 40 kilos, kilometers plus stabilization. The speed of fly is from 2 or 5 meters by second for a slow for precision. The maximum target depth is around 2 kilometers. We require stability and extremely high low vibration. This is a technical specification of frame size. We have the Farbon Kyber, we have all of system, the dimension. Okay. Make a resume of characteristic. We have cycle lifetime. We acquire measurements of gravimeters of every week, every times of 0.22 seconds. We require a stable or always slow motion during cycles. The limits of this speed is clear that you not exceed the velocity of 205 meters by seconds. Quantum gravity measures film variation in gravity caused by the density constant and gas hydrogen pocket presence. And so this is the parameters for a small target. You have a very weak signal at 2 kilometers. Deep target require ultra noise reprocessing detection. Fast service reduce clearly when you exceed this velocity of acquisition, you can reduce the accuracy. Okay. So we illustrate, we have passed the first part of webinar, and we are going to the second part. So the first part is to make a general introduction to unconventional gas, the type of unconventional gas, the resource, and the project which for ConocoPhillips are involved. Our partnership with ConocoPhillips to develop these new technologies for quantum gravimeters. And the second part is just still a technical part of webinar, because we try to respond, to answer to a real trouble of the capturing, the actual capture technologies of unconventional gas and also hydrogen. As we just explained in the first phase of webinar, unconventional gas have a sometimes critical condition or recovery, and as we just involved in South Africa project or also in Australia, we have some critical or very particular geological situation with refilled fracture like this, or and conventional gas sometimes cover a really extended area. So it's not so possible to make 100 drilled points. And we have also the trouble of diffusivity of gas along the fracture. So we have several trouble to to capture the unconventional gas and also hydrogen. So also in this case, we are starting to have a new approach, new technologies for capture is the second part of webinar. We have several also just other companies, other big companies, for example, that are working also in Permian Basin in USA, or like ExxonMobil or others. We have in the past tried to affront this. Today, for example, we have the ionic zeolite system. Adsorption injected sometimes a quantity of zeolite permitted the capture technologies have deployed patented technology that used liquid zeolite materials to stimulate and recover unconventional gas. And we have two effects, because generally zeolite is a waste mineral that is able to purge all ambient and to specify target and capture methane and CO2 gas mineral. Advanced soil solvent research and field testing in 25 have focused on using advanced solvent, including the metal organic framework that is called MOF, which offer high selectivity for CO2 and methane compared to conventional farming system. So this is a detail of geological trouble for unconventional gas at microscale. Effectively, what is the trouble? Analyze the time of migration from source rock, that generally can be source but also the trap rock, is essential to choose the best system to capture the unconventional gas and also hydrogen. Gas does not migrate in a classical sense or in a classical way. So it is released, mobilized, and redistributed in a pressure-driven pulse through a nano and micro fracture. And as we just said, if you are following all of part of webinar, in the first part we talk about the actual technologies to map the fracture, and our contribute to developing the new scanner image that is able, with new scanner image, I check to refine the so the new scanner image, electrical image, was able to have a resolution from 2 to 5 millimeters, a really high resolution to map the fracture. Because it's so important, because you are able to fracture all of types of fracture, filled fracture, refilled fracture, fracture that are isolated, fracture that are connected, and establish which will be the pathway of migration, and also the preferable pathway to be developed for gas, conventional gas extraction. You have two examples. For the Carboniferous shale rock source, you have the microfracture, the gas redistribution for nanopores and high pressure, and we have organic kerogenic pore with the mixing zone. This is a complicated situation, methane and water. And we have the second type of reservoir, tight sandstone. Into tight sandstone you have the microfracture, but also the pore flow. So the pore flow is really complicated because you need to isolate the section or isolate the multiple section, and apply technologies to extract this. Also monitoring the surface for compactation and like this. The details of the geological trouble of unconventional gas at microscale, four coupled process govern mechanism of migration at microscales. The first is diffusion, the second dominated by nanopores, the second is Kuznets diffusion, the third is the desorption. Gas is initially absorbed on kerogen, controlled by the pressure drop and temperature, and the first is the pressure-driven flow microfracture connected pores. So why we are using the new electrical scan image to study microfracture, which will be the fracture that are connected or not connected. Microfracture this quantum gravitors to identify the zone, the different type of zone with the resolution of 10 meters, 5 meters. Why it's so important to analyze the microscale timing? Because you have a first phase that we have gas generation, kerogen cracking. Gas from kerogen pressure builds locally. Second phase is overpressure build up. Internal pressure exceed. Rock have passed to a tensile state and capillary entry in the pressure. So we have a nanopore expansion. Nanopore. If you are considering nanopore extraction, you can, for example, not apply metal MOF organic framework, but you can use a different type of system of capture. Phase 4 is microfracture, and if you are in this situation and you have the presence of capillary and connected internal vacuum, you can apply easily the Schlumberger electrofracturing to create the microfracturing and connected all of porous and fracture. This is the true migration trigger, and the gas moves from kerogen, so you stimulated the expansion of the gas from kerogen to matrix to the surface rapid. So migration became pulse-like and not continuous. So you can control the evolution of reservoir. Redistribution, the gas was redistributed into larger pore, into fracture nectar, possibility into adjacent layers. Phase 5 is equilibrium, pressurized and absorption reach balance. So why is it so important to analyze the microscale timing, analyze that it will influence the choice of capture system and fracture. Electrofracture will be easily applied in this case. What controls efficiency of micromigration? We have some positive factor. We have an increase of TOC, more gas, affluence of more gas in the upper part, high breathless, more fractures, overpressure. This is a physical phenomenon driven by the electrofracturing, by migration, and perfect for, in this case, we can perfect apply the ionic zeolite, the AEL system absorption technologies. We have a cathodic reaction that linked to some of these, especially when we are working with hydrogen. One of the trouble of hydrogen molecularity that is really too small, and you need like a system of convention of an unconventional system to bring in surface this. Iconic zeolite absorption capture technology has several applications. Carbon capture storage is clear. Separation, in this case, for example, of hydrogen from CO2, methane, and other impurities. Removing also CO2 and all pyritic gas can be create a flare. Industrial gas separation, oil and gas separation, for example, remove CO2 and pyritic gas from natural gas. And so we are testing with successfully using this, for example, in some wells in which the content of sulfurs is very high, and use all of in different phases of operation, use the risk of flare or bubble flaring. Iconic zeolite adsorption capture technology overview. The iconic zeolite-based material functions with ionic species to enhance selective absorption. So this is a scheme of gas absorption, the LZ gas absorption and regeneration cycle. You can separate with this different type of ionus, flare gas ionus, or clean to the clean gas, and the mechanism is based on gas are absorbed via electrostatic interaction with ionic sites. Poor confinement affects in zeolite and chemioabsorption if reactive ionus are used. This system is still to develop it, and we have also others application for that we are working by Schlumberger. Another technology is based on nickel graphene. So the nickel graphene is still a new type of reactive casing, and we can easily install for these diameters, not where we prevent all of water infiltration environment. We have a conductive graphene layers, a catalytic reactive, and permitted with the catalytic reactive to separate, for example, all of part and extract hydrogen. I want to show you another. Okay, so this is just in testing, but it still function, and it's clear the graphene nickel, in this case, this new type of casing is really specific for hydrogen generation in dry formation. See, there is no question at this time. I want to really thanks for your attention, and I hope to meet us in our office, Calgary, Cape Town, Perth, and Norway. Thanks for your attention. For question, you can send an email or you require materials.